Right, in question 3 we're looking carefully at the positive and negative values inside the square root. So in part A we can see that this first part is 13. 13 squared is 169. Now this inside part, when we square a negative value, it becomes positive. We also know that the degree of the square root is 2, so these cancel out with the exponents on the inside here. So this will actually become 12 here. So with the negative sign, don't forget, we have minus 12. Same thing here for the minus 11 squared. The part inside, this will all come out as positive. With that positive sign, positive 11. If we simplify these, we have 24 subtract 12 gives us our answer of 12. Okay, in part B, we have, let's look at the numerator first. Square root of 4, I think we should know, is 2. Now this part here, where we have the degree being odd, it is possible to have a negative value inside that square root to give us our answer. So don't forget, we still have this minus here, so we should write that in minus, but then also the following part, the answer is minus 2 because the 2 cubed is 8 here. 81 we should recognise as 3 to the power of 4. And if we add this to this here, again from part A, remember that this bit inside here was positive. So hopefully we followed all of that. If we say 2 minus minus 2, we are adding it. 3 plus 3, 6, and we can simplify those to get our answer 2/3. Great, so for part C, if A is less than 0, we know for sure that it's negative. And so if B is bigger than 0, we know for sure that it's positive. Right, so that's the very first important thing to see here. Now if we take the square root here of our negative value, it will become positive. So to make sure that this value is positive, we should say minus the negative value. That's very important. Remember that A was in fact negative, so that's why we have this minus here. So for B, we know the value is positive, so plus B. And now we need to consider, for these two parts here, we've got A minus B. Now we need to decide, is this value positive or negative? So let's think of an example. Let's say minus 2 minus 5, let's say, and we can agree, hopefully, that that's going to be negative. All right, but we know that when we take the square root, when we square it, it's going to be positive. So that when we say A minus B, we're going to have to consider making that negative so that the whole thing is a positive value. Let's just explain that quickly again. A minus B is negative value. The squaring makes it positive. To show that positive value, we're going to have to say minus this negative value. So remember, so this whole thing here will come out as positive now. So that's very important. Hopefully you've got that idea. So now we've got the cube root here. So negative values are no problem inside the odd degree. So that value can be negative, and it's just A minus B, which we remember is negative. Perfect. All right, so hopefully we've got our head around that. And now if we subtract A here, we'll have minus 2A in the numerator. The negative multiplying B here would make that positive, so plus 2B. All of this is over A minus B. So now the very last thing we want to do is to simplify this fraction, and we can do that if we can have a common multiple in the numerator and denominator. So luckily we can change the numerator here to look like the denominator A minus B. So if we look at the first term, we would have to factor minus 2 so that we have minus 2A. And luckily that works. When we multiply out, we do get plus 2B. So now we have our common factor. We can cancel in the numerator and denominator, and we see our answer is minus 2. Alright, so in D we have lots of square roots here. It looks very complicated, but we're going to break it down one step at a time. So first thing we should look at is the inside value here, the cube root of minus 8. Remember, odd degree, no problem with the negative, that's just minus 2. When we look at the next part, we've got the square root of 27 minus 2. Well, that's the square root of 25, which is just 5. So that's no problem. So this bit here is 5. We look at the next part, and it's the fourth root of 11 plus 5. So that's the fourth root of 16. 16 we should recognise as 2 to the power of 4. So that means when we take the fourth root, it's just 2. So this whole bit here is actually just 2. Looks very complicated, but just 2. And now if we just take the last part, we have the fifth root of minus 34, and all the rest of it is equal to 2, as we've just seen. So this is going to be the fifth root of minus 32, and 32, I can hear you saying, yeah, that's 2 to the power of 5. Remember, odd degree of the root, negatives are no problem inside, so this is the fifth root of minus 2 to the power of 5. The degrees cancel each other out, and our answer is minus 2 there. So hopefully that video helped, and I'll see you in another video.